So this lesson has to do with specifically converting decimals to fractions, as opposed to the last video lesson, which converted fractions to decimals. And in many ways, this conversion is actually easier, because when we name a decimal, we actually name the fraction that goes along with it at the same time. So we'll go through a quick review of the things that we need, an example of showing how the decimals and fractions are related through the process of converting decimals to fractions, and of course a few examples at the end for you to work through on your own. So the first question, which is critically important no matter which direction that we're going, is why can we actually convert between decimals and fractions? And primarily it's because they're used to represent the exact same values. So if we look at some common fractions and decimals that are usually known what they are, we know 1/2 is the same as 0.5, 5/10, which when we use 5/10 as the name of the fraction there, that's what we get. So in this case, we can see 1/2 is the same as 5/10. We know this to be true. This is probably the most commonly known decimal. Other common decimals are 1/4 represents 25 hundredths, commonly represented or understood by using a quarter, which is a quarter of a dollar, represents 25 cents out of 100, and so you can remember it there. But these represent the exact same values. Because they represent the same values, we can find a way of converting between them. So let's take a look at something like 45 hundredths. And we're going to look at it from the point of view of this 100 square grid here, because this grid in total represents our 1. Each of these little squares then represents 1/100th of that grid. So we can find and color in 45 hundredths of it. And so let's do that with, I'll grab a highlighter here so we can make it a little bit easier. These 4 sets of 10 and this set of 5. Keeping all of these together, this that's colored here is, and then outlined in yellow, is 45 hundredths. If we count them, we can go back and count and double check. Otherwise, we can see that there are 45 out of the 100 squares colored in. So, going back to how we start learning about fractions, where we talk about numerator over denominator. The denominator being the total number of parts that we have, or the total set, which is, in this case, 100. And the numerator being the number of things that are unique about that set, or the things that we were talking about specifically. And in this case, we're talking about those 45 squares that we colored in. And if we read this fraction, before we simplify it, we read it as 45 hundredths. And if we read this decimal, not using the more informal, that's 0.45, if we read it properly using the place values, this is also 45 hundredths. So if we read this decimal, 45 hundredths, and write the fraction by the same name, 45 hundredths, we've actually created the fraction that it represents also. And this actually holds true with no matter with any decimal or fraction that you use, no matter the decimal or fraction. In this case, we have what is informally 0.458, otherwise known as 458 thousandths. Now, it's really difficult to represent on a page that has 1,000 different squares, and I could try to put it up on the video here, but the squares would be so small it's not even worth trying to discern what would happen. But we can use that trick that we had before, where we name the decimal and we can use it to write the fraction. But I'm actually going to show you a different way of doing it also. So if we name the decimal as 458 thousandths, which is what it is in place value, we can write that fraction here, 458 thousandths. The alternative to that, if you're not particularly handy with naming the place values for the decimal, first I would recommend you go back and look at the lesson on decimal place values so you can brush up. But secondly, we can look here and note that there's 458 here. Well, that's going to end up being the numerator of our fraction one way or another. And now we have to figure out what needs to go in the denominator. Well, the decimal place values say these are tenths, hundredths, thousandths. Since our smallest place value here is in the thousandths, that 1,000 is going to become our denominator. Alternatively, one last way, you can make each of these numbers into a 0 and represent the decimal point as a 1. If at that point you get rid of the decimal point and the numbers in front of it, then you have your fraction always. So 3 different ways: naming the decimal and turning it into a fraction, writing the numbers that you have over the smallest place value, which in this case is thousandths, or writing a 0 underneath each of the digits and a 1 under the decimal point, which is a handy way of finding out what place value you're actually talking about if, in particular, we have a very large decimal. So, changing decimals to fractions. This strategy that we have recognized here is identifying the smallest place value using the decimal. You write the entire decimal portion of the number, so in the case before, 458, as a fraction over the smallest place value that's used. The smallest place value that's used, the one that represents the smallest part of a number, is actually the largest number in this case, which is 1,000, because a 1,000th is a smaller value than a hundredth or a tenth. So, keeping that in mind, being able to either write the name of the fraction itself, transform all the numbers into zeros, making the decimal point into a 1, because that is how you actually can find, as a shortcut, the place value for the decimal, or writing the entire thing over the smallest place value that we have. Take a look at these 4 problems here and see what you can do with them in terms of changing decimals to fractions. So if we start in the upper right-hand corner, left-hand corner, and I'll number these so we have a idea of what we're talking about. We don't have to refer to them by the space that they're in. On the upper left-hand corner, number 1, we have the decimal 375 thousandths. So we just write the decimal as 375 thousandths. Now, if we were to simplify this decimal, and if you're not familiar or shaky on simplifying the decimal, go ahead and refer back to the lesson on simplifying fractions. This simplifies to 1/8. Alternatively, we could recognize that the 3, the 7, and 5 are in 3 different place values for the decimal. The 3 is in the tenths, the 7 in the hundredths, and the 5 in the thousandths. Because the 5, the smallest place value, is in the thousandths, we write it as 375 over 1,000. For problem 2, we have 3, which is a whole number, and we leave it like that. We're not going to transform it into an improper fraction because a mixed number works just as well. And in this case, you may not know automatically what the smallest place value, which in this case is also a 5. But if you were to read that, we have 2,485 of something. And we have tenths, hundredths, thousandths, 10,000ths. So 3 and 2,485 10,000ths. Now, we can simplify this by dividing them both by 5. If we divide numerator and denominator by 5, we get 3. 2,485 divided by 5 is 497 over 10,000 divided by 5, which is 2,000. Now, 497 doesn't share any factors with 2,000, so this is the simplest form that we have. If we go down to number 3, which is 24 and 339 thousandths, we can have 24. And using another property, if you're not entirely sure what place value that is, again, apart from brushing up on your place value, you can write the entire thing and take the shortcut for finding the place value, which is transform each of these into a 0 and add a 1 at the beginning. Now, being able to do that and knowing how many places you need to add to the bottom as the shortcut for finding the place value becomes obvious when we look at number 4, which, if we just read it, is 5 10,000ths, or simplified 1 2,000th. However, this is not 5 tenths. If we were to transform just the 5 into a 0 and add the 1 for the decimal point, this would be 5 tenths, but that's not what we're looking at. The smallest place value that we have is 5 10,000ths, so the 5 must be placed over the 10,000 when we transform the decimal to the fraction. So once more, to change a decimal to a fraction, we need to identify the smallest place value used in the decimal and write the entire decimal portion of the number as a fraction over that smallest place value. This is what we do when we name a fraction based on place values, such as 458 thousandths. We identify that the 1,000 is the smallest place value, and read the number as it is. Or if it's a particularly long number, if for example one of these went out for 6, 8, 10 decimal places, we can take each of those decimal places, form them into a 0, and make the decimal point a 1, and that will give us the shortcut to finding what the place value is for that decimal.